Assalamu alaikum, dear students. Today's topic is test of hypothesis about a population mean mu. We are going to test mean mu against a specified value mu naught. There are different forms of hypothesis and different cases are considered. We will consider a table here. This is a algorithm in which you can see there are three different forms which are shown in the form of rectangles. Left hand side equal to mu naught. In the middle, hypothesis, null hypothesis is mu less than equal to mu naught. On the right side, mu is equal to mu naught. These are the three cases which depends on the sampling distribution of x bar whose testing of hypothesis is further divided into two categories. We will consider two cases of the testing of hypothesis, the testing of mean and testing of proportion. The testing of mean is further divided into two cases for single mean and for two means. For single mean, it's mu, and for two means, it's the difference of two means mu1 minus mu2. Similarly, in the proportion, we deal with the two kind of testing. For single, pi is equal to pi naught, and for the two proportions, which is we will consider these four cases of testing of hypothesis here, in which first one is right now we are doing. So testing of hypothesis of mean, testing of mean. So hypothesis is H naught mu is equal to mu naught. We have three different forms of null hypothesis. First form is equality, or mu less than equal to mu naught, or mu greater than equal to mu naught. Any one of the form can occur against the alternative hypothesis of inequality, greater than and less than. So these are the three cases of null hypothesis and alternative hypothesis. These are the pairs actually of null hypothesis and alternative hypothesis. We will discuss two cases here. If the population variance sigma square is given, or if sigma square is not given. So we will deal here the two cases of the situation of the normal population in which sigma square is known and sigma square is unknown. So we will write here first case sigma square known, second case sigma square unknown. If sigma square is known, then obviously either our sample size is small or sample size is large, we will use Z statistic. If sigma square is unknown, then we will further check one more condition related to the sample size small n. So we will check that the sample size is small or sample size is large. There are two cases, n is less than 30 or n is greater than 30. If n is less than 30, if n is greater than 30, we will use Z statistic, and if n is less than 30, we will use T statistic. Question 3a from the exercise 13.2. A random sample of size 36 is taken from a normal population. So we will highlight here the sample size. The sample size is 36 and it is taken from the normal population. So these two things are available, the sample size and the normality. with the known variance. So sigma square is given and it is stated here 25. So sigma will be 5. Known means you have to write sigma square is equal to specified value which is 25. And the mean is x bar 42.6. The null hypothesis is clearly mentioned against the alternative hypothesis clearly mentioned, and alpha is 0.05. Alpha is the probability of committing type 1 error. Now we will solve this question 3a from exercise 13.2. The first step is the null hypothesis, which is given in the statement mu greater than equal to 45 against the alternative hypothesis h1 mu less than 45. So first step of testing of mean is the statement of null hypothesis and alternative hypothesis h1. This is our first step. And the second step is the level of significance is mentioned, which is alpha, and it is given as 0.05. And the third step, which is in the testing of hypothesis, is the test statistic. We will write here the test statistic. Before writing the test statistic, we should know that sigma square is known or not known. In our case, sigma square is known, 36, which is large. So we will use Z and X bar is given as 42.6. Bar is 42.6. Test statistic to be used is Z statistic because our sigma square is given and sample size n is greater than 30. Therefore, we will use Z score. Its value is, its expression is, Z statistic is X bar minus mu over sigma, it's mu naught actually, which is given in the null hypothesis. Sigma over under root. So this is the value, this is the expression of Z statistic. We will substitute our values and obtain the result in the fourth step, which is for the computation. In computation, we will consider x bar, mu naught, which is 5, sigma, which is 5, n is 36, and we will substitute all these values in z statistic and calculate it and obtain its value. This is our fifth step, critical region. We will plot normal distribution, normal curve, and we will alternative hypothesis having mu less than 45. Whenever it is less than, then we will locate our critical region on the left tail. If H naught, this is our critical region. Its probability is 0.05, which is given as alpha, and the remaining is 0.95, which is in the acceptance region. On the right tail, it is acceptance region. On the left tail, it is the critical region, rejection region. And the critical point is obtained by Z alpha. Alpha is 0.05, so it's Z 0.05. From the table, we will learn that its value is 1.645. And since it's on the left hand tail, so its value will be minus 1.645. So we will locate Z 0.05 in the table and obtain its result as minus 1.645. In the middle, the Z score is 0 and X bar scale is in the middle 45 because we are going to test that the mean of the distribution is 45. So the upper red line shows the X bar and blue line shows the Z scale. We will state here the critical region as reject H naught if Z calculated Z calculated less than minus 2.8. Reject H naught if Z calculated less than Z alpha, which is Z 0.05. Since in the alternative hypothesis mu less than 45, so we'll write here ZC less than Z alpha. The critical region is directly related to the H1 alternative hypothesis. If it is less than sign in the alternative hypothesis, we will shade the left tail of the normal curve and we will write here reject H naught if Z less than Z alpha. Its value is minus 1.645. Now we will write the sixth step, the conclusion, which is based on this statement, reject H naught if Z less than Z alpha minus 1.645. Since our value minus 2.88 is less than 1.645, therefore we reject H naught and conclude that our mean is less than 45. We will again make the normal distribution. 1.645 is on the left tail minus 1.645. This is our critical value. And minus 2.88 lies in the shaded area of the normal curve since its value is less than. Z scale is starts from minus infinity to plus infinity and in the middle its value is the zero, the mean of the normal curve, standard normal curve, and minus 2.88 is pointed out here on the left hand in the shaded area. Yes, you are now pointing the right place that minus 2.88 is anywhere in the shaded area. Whenever our calculated value lies in the shaded area, it means it's rejected. If ZC is less than Z alpha, we will reject H naught. Whatever is mentioned in H naught is rejected. We accept the other statement which is written in the alternative hypothesis. So we will write here in the conclusion since our calculated value lies in critical region, therefore we reject H naught and conclude that H naught is not less than equal to 45. H1 is accepted, which is mu greater than 45. So we will write here that and conclude mu greater than 45. This is our CN, our result, our conclusion about the statement. Thank you so much for thank you so much for watching this video. Allah Hafiz.